In last term the power is 3. In last term the power is 4. So when we want to write down mu 3 dash, then we start with mu 3. Then we will write start with mu 3 dash. So mu 3 dash minus 3. Then mu 2 dash. Sorry, here it is mu 2 dash. Mu 3 dash. Then one power will be decreasing for each one. For first one, and the mu 1 dash will remain fixed. So minus 3 mu 2 dash into mu 1 dash. Then mu 1 dash square, like it will increase. But here it is the end. So plus 2. 3 minus 1 is 2. Mu 1 dash whole cube. The last has the same power as that of mu r. Mu 4 dash we will start from mu 4 dash. Mu 4 dash means mu 4 dash minus 4. Minus 4. Then mu 3 dash into mu 1 dash. Plus 6. Mu 2 dash, now mu 2 dash, and mu 1 dash is fixed, mu 1 dash square, its power will increase now. And the final term is here, minus is there, and 3 is here, so minus 3 mu 1 dash whole raised to 4. Likewise, we can also write down mu 5, suppose. So for mu 5 here, we will write down 1, 5, 10, 5, and then 1. Last terms we will combine this one and we will separate this one. So last term we will have 4 coefficient and mu1 dash whole raised to 5. So we are starting from here 1. It is so mu 5 dash. Then minus sign will come. Minus plus minus plus. Okay, minus 5. Then one power will be reduced. Mu 5 dash then mu 4 dash into mu 1 dash. Plus then plus 10. 10 into mu 3 dash now. This is reducing by 1. So mu 1 dash whole square minus 10. 10 into mu 2 dash now and mu 1 dash whole cube now. Okay, mu 3 dash then mu 2 dash. Then the last one is plus 5 minus 1, that means 4. Plus 4 mu 2 dash, now it is the ending of the term. So mu 1 dash whole raised to 5. Mu 1 dash whole raised to 5. Because here we will have to put mu 1 dash and then it will become mu 1 dash raised to 4. So mu 1 dash into mu 1 dash raised to 4 is mu 1 raised to 5. Likewise here also mu 1 dash into mu 1 dash cube. Because after mu 2 dash it will become mu 1 dash into mu 1 dash cube. That means mu 1 dash 4. So these formulas are very easy to remember. Okay? And the same formula we can get for mu r and mu r dash. Simply you will have to replace each and everything by mu instead of mu. This is known as mu, Greek letter, and that is mu. Suppose if you forget this formula, then this formula can be derived very easily because we know that mu2 equal to 1 upon n sigma fi into xi minus x bar whole square. We also know that mu2 is sigma square, it is the variance. But to derive this formula, that means to derive the relation, that means mu r dash equal to 1 upon capital N sigma fi xi raised to r. So we want to make the use of this formula to relate. So here what is this? Sigma fi xi square minus 2xi into x bar plus x bar square. You can see. Okay. So we will split out this one. So first of all we will get sigma fi xi square minus here is 2. X bar will be common divided by n sigma fi into xi. Okay. Plus here x bar square will be common divided by n sigma fi only. So what is this? This is what? This is mu 2 dash from this one. You can see for r equal to 2 this is mu 2 dash minus 2 x bar upon capital N. This is what? This is again sigma fi xi upon capital N is x bar. So it will become x bar square. And plus this is sigma fi. Sigma fi is capital N. So capital N and capital N will be cancelled. So it is x bar square. So this is what? Mu 2 dash minus x bar square. But we know that x bar equal to mu2 dash. X bar equal to, mu1 dash, x bar equal to mu1 dash. This already we have derived. So this is mu1 dash whole square. And you can see this formula has been obtained. Similarly, if we want to obtain the relation for mu3, then we will have 1 upon n sigma fi into xi minus x bar whole cube. So here you can see that this is obtained as fi. This is what? Xi cube minus 3xi square into x bar plus 3xi into x bar square minus x bar cube. You can see. So if we split out this term, then we can get sigma fi xi cube. This one is. From this we will take x bar as common upon capital N, sigma xi square plus 3x bar square will be common. So sigma upon n, capital N, 1 upon n is here. So this is sigma xi. Xi will remain as it is. 3x bar square is taken common. So x bar cube here again taken common. So 1 upon n into sigma fi. Here fi into xi. Fi is remaining to multiply with all this one. So here is again fi. So this is what? This is nothing but here you can see that this is mu3 dash minus 3 x bar 1 upon n sigma fi xi square. This is what? This is mu2 dash. This is what? 3 x bar square and sigma fi xi upon capital N is again x bar. So this is xi cube and this is x bar cube because sigma fi equal to capital N. So this will be cancelled. So 3x bar cube minus x bar cube will be cancelled. So it will become 2. And we know that x bar equal to mu1 dash. So if we put x bar equal to mu1 dash, we get this formula mu3 dash minus 3 mu1 dash into mu2 dash plus 2 mu1 dash whole cube. Likewise, we can obtain the formula for mu4. Okay? So have you remembered this? How these formulas can be derived? These are very easy to derive. Okay? If you want, you can also derive the formula between mu r dash and mu r. But then what we have to do? We know that mu r dash equal to 1 upon n sigma fi xi raised to r. This is the general formula. So 1 upon n sigma fi xi minus x bar plus x bar we will write down. So these two will be cancelled finally, and we will combine this as a single one. So we will have the formula for this is suppose we want to find out mu for mu2 dash. Mu2 dash has 1 upon n sigma fi xi minus x bar plus x bar whole raised to 2. So we will consider this as single one. So 1 upon n sigma fi, this is what? Xi minus x bar whole square plus 2xi minus x bar into small x bar plus x bar whole square. So we split out these terms. So 1 upon n sigma fi xi minus x bar whole square plus 2x bar here is common. So 1 upon n sigma fi into xi minus x bar plus here is what? X bar square will be common. So x bar square upon capital N into sigma fi. So this is what now? This is what? This is nothing but mu2. Mu2 we already know. So and it is what? 2x bar upon capital N fi into this is mu1. This is mu1, but mu1 is 0. mu1 is 0. And the last one is x bar square because this is capital N will be cancelled. So mu2 dash equal to mu2 plus x bar square. So we can obtain the formula for this one in this way. Okay? And you must have observed x bar is mu1 dash. So you can see that mu2 dash from this mu2 dash equal to mu2 plus mu1 dash square. So it is mu2 plus mu1 dash square. So we can find out the relations in this way. And in more general form, if you want to find out the relation between these one, then you can also use the formula mu r equal 1 upon n sigma fi into xi minus x bar whole raised to r. Then you can split this one, xi raised to r minus rc1 that means r, xi raised to r minus 1 into x bar plus rc2 is r into r minus 1 divided by 2 into xi raised to r minus 2 into x bar square plus rc3 is r into r minus 1 r minus 2 divided by 3 factorial means 6 into xi raised to r minus 3 into x bar cube. And you can proceed in this way to find out the value, plus minus plus, then it will be minus. So you can put r equal to 2, 3, 4 to find out these formulas in a single step also. So have you remembered this one? So you will have to remember this formula, and once if you will remember this formula, I have also shown to you how to remember these formulas by using the Pythagorean triangle. Now let us see about skewness. Here, this is very simple. Nothing is difficult. Carl Pearson's coefficient of skewness. So in examination, you will be asked to find out Carl Pearson's coefficient of skewness, or simply if you are asked if Carl Pearson's word is not used, then it may be asked simply to find out coefficient of skewness. And this you can find out by using mean minus mode divided by standard deviation. So you will require to find out your mean and mode, and then to find out standard deviation. So what is skewness? Skewness is nothing but the degree of skewness is the degree of asymmetry. Asymmetry means what? The curve when it is not symmetrical. For example, let us see, if we draw the graph of based on the data, if it is the frequency line, and if these are the classes whichever they are given, then if we get the graph of this kind graph, then here it will be more at the peak level, then we will have the median, and then we will have the mean. That means here you can see that mean is on the right side. Okay, mean is on the right side of mode. Mean is right side on the mode. So we can say that this graph is positively skewed. The graph is positively skewed. Okay, that means the distribution whatever we get is positively skewed, and in this case we can get graph of the graph this one. Suppose we get a graph of this kind, then we will have the mean on right side of the mode. Mean is on the right side of the mode. Here is mode, and here it will be median. So we can see that mean is on left side of the mode. Mean is on the left side of the mode. So we say that this graph is negatively skewed. So this is the concept of skewness. You can see. Okay, but this is the measurement based on mean. So we can see that the structure of the graph, which is this is positively skewed and this is negatively skewed. But if we get symmetric graph, what will happen? Symmetric graph means from the peak level both sides are same thing. That means the curve, shape of the curve is symmetrical on the left side and right side of this one. So that means here when mean and mode are equal, mean and mode, here mean equal to mode. Mean and mode are equal, then skewness is 0. Skewness is 0, that means it is not skewed. It is not skewed, that means it is not asymmetric. It is not asymmetric means the graph is symmetric. The graph is symmetric. Okay? So now this is the graphical explanation of the skewness. And this formula is given to us, mean minus mode. But we also know that mode equal to 3 median minus 2 mean. We have already seen this formula during the study of mean, median and mode. So if we put here mode, the value of mode over here, 3 median minus 2 mean. Minus 2 mean means it will become plus 2 mean. Plus 2 mean means 3 mean. So this formula will become 3 mean minus median now, divided by standard deviation. So this is the formula regarding, this is the formula for mean and mode, this is mean and median. The same formula by using this formula, and this formula we already knows. Now the coefficient based on central moments. So this Karl Pearson's coefficient of skewness is based on mean, median and mode. But now we will see same coefficient of skewness based on central moments. So this coefficient is equal to, and we will denote this by beta 1. Here this can also be denoted by beta 1. So based on central moment. So this is nothing but mu3 square divided by mu2 cube. So here we require to know the values of mu2 and mu3. And mu2 and mu3 we can find out this one by using this formula or by any other formula. And mu2 is nothing but sigma square. It is the variance. So Karl Pearson's coefficients based on central moments is mu3 square divided by mu2 cube. So here we can see that if beta 1 is less than 0 or beta 1 greater than 0 or beta 1 equal to 0, that means skewness is measured based on its negative or positive sign. So if it is less than 0, then we can say that the skewness is negatively, the graph is negatively skewed. And if beta 1 is greater than 0, then we say that it is positively skewed. And if beta 1 equals 0, then the graph is symmetric, as we have observed in this case also. That means when mean equal to mode, then the graph is symmetric. So you may be asked to find out coefficient of skewness based on central moments, and you can use this formula, and based upon its sign you can say whether the data, that means distribution data, is negatively skewed or positive skewed, or it is distributed symmetrically. Okay, so this is very much simple to remember. So you must remember this formula, because we will make use of this formula repeatedly. Now let us see about kurtosis. So here kurtosis is the measures the degree of skewness. Kurtosis measures the degree of skewness. Kurtosis measures the degree of skewness of a distribution. This is also very simple, and this is denoted by beta 2. So beta 1 is denoted by coefficient of skewness, and beta 2 is kurtosis. Beta 2 is obtained as mu4 upon mu2 square. mu4 upon mu2 square. In both cases we have divided them by mu2. Here by mu2 cube and then by mu2 square. mu4 by mu2 square. Okay, and here again we have three types depending upon the value of beta 2. Beta 2 may be greater than 3, beta 2 may be less than 3, or beta 2 equal to 3. So we will measure this value based upon 3. Okay, based upon the value 3. Now when it is beta 2 greater than 3, then the curve is known as leptokurtic. Leptokurtic curve. The curve which will be obtained as leptokurtic. If beta 2 less than 3, then this is known as platykurtic curve. So if you are asked to find out the value of kurtosis and then to comment on the curve of the distribution, then you can say if you will get beta 2 greater than 3, then beta 2 less than 3, then it is platykurtic, and if beta 2 greater than 3, then it is leptokurtic, and if beta 2 equal to 3, then we say that the graph is symmetric, or it is known as mesokurtic. Okay, so these are the types of the kurtosis which are based on value 3. Okay, and then friends, we will see examples based on the facts which we have seen about moments, skewness and kurtosis the next time. Okay, thank you very much.